All right, this video is going to work through that second problem that was in that calorimetry set in your notes. Again, I've copy and pasted the prompt in the new slide here. So let's go ahead, and this time what we want to do is when I'm going to read it, as we read it, we're going to populate our picture with the appropriate numbers and try and label as we go. So a 12.18 gram sample of a shiny orange-brown metal. So the 12.18 grams, the grams tells you that it is mass. So the 12.18 grams is the mass of the metal. So we're going to call that mass solid or M solid. Okay. It is heated to 65.00 degrees Celsius in a controlled water bath. And then the metal that is at 65 degrees is added to water. So the metal, when it's added to the cup initially, is 65.00 degrees Celsius. This is going to be your T initial for the metal. Okay. That metal is added to 25.00 grams of water. So the water is 25.00 grams. The unit of grams tells you this is this is the mass of the water. Okay. And the water temperature changes from 25.55. So 25.55 degrees Celsius is the initial temperature of the water. Okay. And it changes from 25.55 to 27.25. I want to make a point again here that although it is the T final for the water, the assumption is that the metal is losing heat and is warming up the water. So at the end of the experiment, the metal is the same temperature as the water. So T final for the water is T final for the solid. So they should be the same. So the water is 27.25 degrees Celsius. This is T final for the water. And it is the same number for the metal. So it is also 27.25 degrees Celsius for the metal. It is very important to note that these two numbers are exactly the same and should be the same. Okay, so be the same T final. All right, so that's really important as a takeaway when you're setting up this for your lab as well. The T final should be the same. All right, remember step one is to calculate Q for the water. So Q for the water is going to be C of the water, which is water is 4.184 joules per grams degrees Celsius. That was given to us in that last little number there, seawater, okay, 4.184 times the mass of the water. The mass of the water is here. It is 25.00 grams times. Now, we're going to go ahead and calculate T final, which is 27.25. Subtract the initial, which is 25.55, both for the water. So we're going to go ahead and do that. 27.25 minus 25.55. And we're going to get 1.7. So this whole thing comes out to 1.7. And then I just want to make a note here, because of the fact that it has two numbers after the decimal. In terms of sig figs, we also want to keep two numbers after the decimal point. Okay, and we are in degrees Celsius. All right, so to find Q water, we're just going to multiply our numbers together. So we're going to get 4.184 times our 25 times our 1.7. Okay, the calculator won't give you the correct number of sig figs, so I usually just drop the 0 and then just go back and fix the sig figs at the very end. So I get 177.82. Now I go back and say, okay, 1.70 has 2 decimal points, but 3 sig figs total. Now we're doing multiplying, so we've got to look at all of the numbers, not just after the decimal. Remember, after the decimal, looking at how many numbers after the decimal point is only for subtraction and addition. And we did do the subtraction of 27 and 25, so that's why we kept the 2 numbers after the decimal there. But now in this next step, we're multiplying, so it is 3 sig figs. 4.184 and 2500 is all 4 sig figs. So these are all 4 sig figs, 4 sig figs. So we're going to go with 3 sig figs. So 177. The 8 does round that last 7 to an 8. So 178 joules. And that is your Q of the water. Remember, the Q of the solid, you've got to change the sign. It's same in value, opposite in sign. So in terms of what is Q of the solid, we end up with negative 178 joules. Remember, we've got to change the sign when it comes to figuring out the Q of the solid. They're same in value, both 178. The Q of the solid is opposite in sign. Now that we have Q of the solid, which is negative 178, that's the amount of heat that was lost by the metal. We can use that to solve for C of the solid. So again, we're going to use this equation that I copied over from the previous slide. And so we're going to say C of the solid, and we're going to populate all our numbers here. Now we're looking at the solid. We're going to change our viewpoint from the water to the solid, so the orange numbers. So the Q of the solid, which we figured out in step 1, is 178 joules. And we're going to divide it by the mass of the solid. So let's go back and look. The mass of the solid is here. That is our 12.18 grams times the T final, which is our 27.25. Subtract our initial of 65.00. Again, both of these values are for the metal. Okay. I again like to figure out what's inside the parentheses first. So 27.25 minus 65 is, 65. I retype that again. Okay. And I'm going to get minus 37.75 degrees Celsius. Again, I would like to keep my numbers, 2 numbers after the decimal, because that's what we do in terms of subtraction when it comes to sig figs. So I'm going to rewrite my equation. C of the solid is equal to our negative 178 joules divided by 12.18 grams times negative 37.75 degrees Celsius. You can either type that all in your calculator or solve the bottom first. I'm going to go ahead and solve the bottom first. So I'm going to go 12.18 times negative 37.75. And I'm going to get C of the solid is equal to negative 178 joules all over negative 459. I'm going to keep my 4 sig figs, 0.79 or 80. Okay, my units are grams degrees Celsius, so grams degrees Celsius. Okay, and again, I'm going to divide those 2 numbers. So our negative 178 divided by my negative 459.8. Okay, and I'm going to end up with 0. The negative and the negative do cancel. 0.387124. I'm not going to write the rest of the numbers because I know that 178 has 1, 2, 3 sig figs. The other number has 4 sig figs, so I'm going to go with 3, 1, 2, 3. I'm going to drop all of the rest. The 0 in front is not significant, although I do need to keep it there just so that I have my placeholder. So 0.387. My units are going to be joules. grams degrees Celsius, so joules over grams degrees Celsius. Please remember to put in your units and remember to take care of your sig figs when you are doing this type of problem. This is exactly what you need to do in terms of the lab, so I really would suggest that you practice these two problems in preparation for the lab work that you're going to do I believe the third lab or the second lab is this calorimetry lab. In terms of the end of this lecture 2 set, make sure you go through this competency checklist and make sure you can do all of these things, understand and use the clinic molecular theory of matter to describe the difference between a solid, liquid, and gas. In particular, you should be able to look at a molecular model or a scale of a sample window and tell me if it's a solid, liquid, or gas. You should be able to describe a chemical or physical property and a chemical and physical change. You should be able to identify a change in matter in terms of a chemical change versus a physical change. And then, of course, you should be able to look at a window on a molecular scale and tell me, is it an element, a molecule, a compound? Is it a pure substance or a mixture? And if it is a mixture, is it a homogeneous mixture or a heterogeneous mixture? You should be able to convert in terms of the units of energy of calorimetry versus kilojoules versus joules, and be able to solve simple energy transfer problems solving for Q, using Q equals C times mass times delta T, and then using that equation and its calorimetry equation, which is your minus Q solid equals Q of the water, you should be able to do the thing that we just did where step 1 you solve for Q of the water and step 2 solve for C or specific heat of the solid. So those are kind of the major points in lecture set 2. Practice these things. Remember that next week you will have exam 1.